Hi guys, welcome back to Road Tutorials Chapter 3, Part 2, where we will start to write some full adder using TDD. In the last video, we mentioned about what is TDD in general and what is full adder in general. So in this video, we're going to look into the implementation of the full adder. So before we start the development, we need to import two things. As usual, it's going to be road and a test package in this case. So yeah, let's just call, and then you need a main function definitely to run your code. I just copy out this code here, and then yeah, just close up the YAML and paste it here. Okay, yeah. So your road implementation here. So can just use this line. Okay, let's go back to tutorials. So in TDD, normally we start by creating a failed test. Let's create a test case that tests for XOR functions. Yep. So we should have a test case that says like your XOR result should be correct for A and B. So we're going to test for the first one, XOR A and B. So let's look at the code. We say that there's a test. It's take on a parameter, a string parameters. In this case, it's going to be what the the your test descriptions. In this case, I just write something like should return XOR result correctly in A XOR B. And we're going to have a for loop because A is going to be 0 and 1, B can also be 0 and 1. So a for loop we will do in this case for I and J is 0 and 1. We expect like when I is equal to J, it's going to be 0. And when I is not equal to J, it's going to be 1. Yeah. Okay. So let's write our implementations. Let's go back to our code and just write test. You see here, it's mentioned descriptions, just like what I said just now. It's going to be a test descriptions. Just quickly, yeah, should return A X or B correctly. Yeah, yep. And then let's think a little bit like we need a for, right? Then like I is equal to 0, and when I is less than 1, then I plus plus. Oops, I think I forget something. And then we need another one. It's going to be orj. It's going to be 0 and j less than 1, j plus plus. So now we have like going to be a simple loop here, and then we expect what we expect the actual result, right? So in this case, the actual result just like XOR AB temporary is going to fail because we don't even have that function, right? Yeah. So in this case, we expect the when I is equal to j, and then it's going to be 0. Else it's going to be equal to 1, right? Yeah. So in this case, XOR is going to fail. So keep calm, keep calm. Everything is under our control. Let us now fix that error. Let's start by define the logic initializations and the XOR operator. So in this case, you can see here. So we have like A and B going to be our logic inputs, and then XOR AB is going to be A XOR B. If you not sure what this symbol is, I suggest you check back chapter 2 where we mention about what is this symbol, right? Okay, so test. We should return XOR result correctly in A XOR B. Hmm. So we can just put A, put I, and B, put J. And then we can expect the XOR dot value dot two integers. Okay, let's implement it. So now let's start by creating our signals. Final A equal to logic, and final B is going to be logic as well, right? And let's see what it takes. Going to take a name, right? So simple one. Oops, what happened? It's a name constructor. Yep. Okay, it's going to be A, B. If so we don't need to specify the width because it's going to be one, right? We mentioned it last time. And XOR AB is going to be A XOR B, right? Huh. So this one's going to be a logic as well. Oops, what happened? Sorry. Oh, okay. We have to use assignment because um unless we declare another signals like finals XOR AB equal to logic, unless we do something like this, else we can just say like XOR A and B. We just follow tutorial. It's going to be A and B. Okay, cool. So let's put the value of I and j into A and B for the validation purpose. But let's do something like A dot put I and B dot put j, right? Okay, so we expect the value of XOR A and B when it is integers is going to run correctly. So just run the test. Let's see. Yep, it says that should return A XOR B correctly. All the tests pass. So let's try to change a little bit. This one to 1, this one to 0. We're just hoping that it fail, right? Yeah, it's failed. Yeah, so means the XOR is working correctly. Can just change back the code 0 and 1. Yep, working fine. So next, we want to create the function of sum. Now you know how to create a test in Dart and wrote the basic things. So now it's time to dive in deeper to create a sum function. So the sum function is represented in XOR, XOR the AB, and a CIN in this case, where we can make it into something like this. So now, just now we have like XOR A and B, and now we want to create another one, sum. In this case, is the XOR of AB and a CIN, right? So in this case, something like this. And then we can put the scene and check for the sum as well. Now instead of we have just I and J, we need to have another test like should return true if result sum similar to truth table I, J, and K. So what K is K going to put in a scene. Yeah. So because now we are testing for the sum, we have to look into A, B, and C in to follow the truth table. And of course, you can code like a bunch of if else now and then, but in this case I'm going to show you how we can use a helper function to help us do it. So in your main function you don't want to have like some logics that related to a declaration of constants, right? Something like you have to declare this in your main, maybe you want it to put inside another function called helper in this case. So let's look at here. There's a helper function called fa truth table, right? So just copy up this line of code. Then at the same time, you're going to create a helper function here where we can just dump our code here, right? It's going to return a fa result dimension here. So you cannot find class. Why? Because the fa result going to hold two property, sum and also cout. By the way, we also need to import the root.dart. So I will just copy out these two components here. Oops. To the code here. Huh. Okay. Now that have to, we have to have a helper, we have to import it, right? Import our helper dot save it. The next thing is we know that there is like a sum. We can just create a sum first in this case. Like sum is going to take XOR AB and probably a cin. I think we need a cin for the logic, right? Cin equal to logic. The name, let's make it easy, just cin as well. Let's see. The next thing is, yep. So the next thing is we need to create a test, right? So to create a test, we can just return true if result similar to truth table. Yep. So let's create it out. I can just copy paste, but instead I want to write it out. So you guys can code along together with me. So should return what is going to be returned. It's going to return true or false, right? Sum. Oh, yeah. So it's returned true. Okay. Yeah. Should returns the result correctly when is follow true when sum. Fine. Okay. Yep. So now we have our test, and then we going to follow this one. So I'll just copy out this one, and then we need to add another loop for cin. It will be for cin. And just limit k. Yeah, just limit k and paste the code here. Okay. Yep. Okay, cool. So now we have the sum. Now instead of testing for the XOR AB, we want to test the sum, right? So just like sum is going to come from FA truth tables, A, B, and C. Let's look into the helpers. What is FA truth table? So FA truth table going to take on three arguments: integers A, integers B, and integer C. And then we're going to have um the logic behind to calculate the sum and also C out. You can see from here, it's like the logic behind it. So never mind. Let's just and then it will return the rest of the FA result. So it's going to be return FA result dot sum or C out. Yeah. In this case, we want to check for the sum, so we can just say sum. I, J, and also K, right? Let's run this one and see how it goes. Huh. Yep. So now we tested our sum and it's working fine. Okay. Let's get back to our tutorials here. Now the last part is create the function of cout. So the cout is going to be XOR AB and cin, right? So now, in this case, I will just copy out the code. Just go through the code together with you all. There's like a final cout is going to is going to have an OR to have an OR. So this the OR things, and it's going to have the first one, the end of cin, and also XOR AB. The end of cin and also XOR AB, and also another one is like A and B or B and A. Yeah. So anyways, this is the function. of the cout. Okay, right. So can just say final. Now we want to create a cout pod. It's going to be an OR that taking two things, right? So the first one is going to, if I remember correctly, is going to be XOR of A, B, is it? Yeah, AND of A and B, and also XOR A, B, and C in. So we have two AND gates here. So first one is A and B. Another one is like XOR A, B, and what is it? XOR A, B, and also C in. Oops, C in. Right? So let's check by the code. It's going to take like XOR AB, no, here, XOR AB and C in, or A and B. And it should return true with result cout is similar to the one with the truth table. Yeah, because if you notice IJK is like the one we set up just now, right? So actually we can just copy out very easily. So just copy out this one, this test. Yeah. So when compared to it's better with compared to truth table. Truth table. And then instead of sum, it's going to be cout, right? And instead of dot sum, it's going to be dot cout. Let's run this test and see whether it's passed. Yep. So now we have built we have built our full header. So our full header have A, B, and C in as the inputs, and then these are our logic or our circuits, right? Yeah. So we have like XOR sum, and cout. Definitely, you can just add, if you want, you can just add intermediate signal, like you want to create an XOR as an intermediate signals, and then you assign A and B to it. Yeah, everything is fine. So in road, you have a lot of creativities to how to design your skit and all those things, right? Okay, so I think that's it for chapter 3 road. Until then, see you next time, and happy coding.